Hello, today we're going to learn about graphing functions or curve tracing using calculus and differentiation techniques. So we'll learn about the first and second derivative test and how we can use them to graph different functions. The function equation tells us about the x-intercepts and basically the points in the graph that we are going to plot. The first derivative of a function tells us about a lot of things. The first is the critical points, or the possible x values for which a local extremum can be found. We can also create a table of signs to determine if a function at specific intervals is increasing or decreasing. If the sign of the first derivative is positive, then your function is increasing. If the sign of the first derivative is negative, then your function is decreasing. Note that if you have a change of sign of the first derivative from one interval to another, this indicates a minimum or a maximum. So if your sign changes from positive to negative, you have a local maximum at that point. If your sign changes from negative to positive, you have a local minimum at that critical point. Now, if the sign of your first derivative doesn't change from the right or from the left of your critical point, then it means that that point or that critical number is not a minimum or a maximum, or it's not an extreme value. To summarize, let's remember that the first derivative test tells us about the possible values of our maximum and minimum, and it also tells us the behavior of our graph at specific intervals, whether it is increasing or decreasing. Next, we have the second derivative test, or your second derivative of your function. The zeros of your second derivative determines the inflection points or the points of inflection. These are the points where your function changes in concavity. So if your second derivative is negative at this interval, that means your function is concave downwards or opening down. If your second derivative is positive on a specific interval, that means your function is concave upwards or opening up. Lastly, we need the points in your original function to know how the graph would look like. So you get the function values at your critical points, at your points of inflection, and also possibly at your zeros. And after that, you can now graph using your information from your first derivative and second derivative test. Thank you for listening and see you on the next video. Bye!